Hi, question number 7 taken from June 2002, Advanced Level Maths HSC P3. In a certain chemical process, a substance is being formed, and 2 minutes after the start of the process, there are m grams of the substance present. In the process, the rate of increase of m is proportional to 50 minus m in brackets to the square. When t is equal to 0, m is equal to 0, and dm over dt is equal to 5. First part, we need to show that m satisfies the differential equation dm over dt is equal to 0.002 times 50 minus m, all in brackets, to the square. And for the second part, solve the differential equations and show that the solution can be expressed in the form of m is equal to 50 minus 500 over t plus 10. Also, for the third part, calculate the mass of the substance when t is equal to 10 and find the time taken for the mass to increase from 0 to 45 grams. And for the fourth part, sorry about that, state what happens to the mass of the substance as t becomes very large. Okay, so here we are. Now we are told that in the process the rate of increase of m is proportional to 50 minus m square. The rate of increase of m means dm over dt, okay, is directly proportional to 50 minus m to the square. That means so dm over dt is equal to k into 50 minus m to the square. We are given that when t is equal to 0 and m is equal to 0, then dm over dt is equal to 5, and we need to show that it is equal to this. The differential equation will reduce to this. Okay, so dm over dt is equal to 5. Here we are. So 5 is equal to k, 50 minus m to the square. All of that can be divided here. Divide by 50 minus m to the square. Therefore, we have k is equal to 5 divided by m is 0, isn't it? So 50 minus 0 is 50. So we have 50 to the square. If you work that out in a calculator, you're going to end up with 0.002. So therefore k is 0.002. Now, in other words, we're saying therefore that dm over dt is equal to k, which is 0.002 times 50 minus m, all to the square. And here we are. This has been shown. That's the first part of the question. For the second part, we need to solve the differential equation. Okay, so how are we going to solve the differential equation? We need to separate the variables. So we have dm over dt is equal to 0.002 into 50 minus m to the square. So solving this differential equation, we're going to separate the variables. The m goes with the m, the t goes with the t. So we have then 1 over 50 minus m to the square. The integral of that with respect to m is equal to 0.002 dt, an integral of that. So again, this is like differentiating 50 minus m, integrating to the power of minus 2 dm. You integrate all of that, you're going to end up with 0.002 t. Integrating that, you add 1 to the power, it becomes minus 1. So you have 50 minus m to the power of minus 1. Divide by the new power, which is minus 1, and you differentiate inside. The derivative of the core is going to be minus 1. And then you're going to get 0.002 t. So that becomes positive. So we have then 50 minus m to the power of minus 1 is equal to 0.002 t, and therefore 1 over 50 minus m is equal to 0.002t plus the constant a. Okay, so now this is the equation, but we need to find a. Now that is quite easy, because we know that t is equal to 0 when m is equal to 0. Therefore I'm going to say 1 over 50 minus 0, which is 50, is equal to 0 times 0.002 plus a. So hence we're going to say a is equal to, this becomes 0, 1 over 50. So that's the value of a. Now what else can we do? We can just substitute that value of a into here. So we have then 1 over 50 minus m is equal to 0.002 t plus 1 over 50. Now that is already an equivalent, but we are told that we should show that it can be expressed in this form. M is equal to 50 minus 500 over t plus 10. Now that's quite a bit challenging if we look at it carefully. So what can we do from here? We can say 1 over 50 minus m is equal to, I can put the denominator as 50. This denominator here is 1. So what is 1 to become 50? So you multiply this by 50, and you multiply the numerator by 50 as well. That's going to end up with 0.1 t over 50 plus 1 over 50. Now since the denominator are the same, so we can express this as 1 over 50 minus m on one side. On the other side you have 0.1 t plus 1 over 50. Isn't it? Because the denominator is the same, so you can write it as just 1. Now therefore what do we have? 1 over 50 minus m is equal to, now that on top here can be multiplied by 10. Why am I saying this? Because I need 10t, I need t, isn't it? So 0.1 times 10, I say 10 over 10 times 0.1 t plus 1 over 50. So we're saying 1 over 50 minus m is equal to, you multiply all of that by 10, becomes t plus 10 over 500. Inverse it, you have 50 minus m over 1 is equal to 500 over t plus 10. So you can send the m on the other side, it becomes m, and you have 50 here, so this one comes on this side, it becomes minus 500 over t plus 10. Here we are, it has been proved. Okay, this is it. Now we need to calculate the mass of the substance when t is equal to 10. So just replace t by 10. So for the third part, the mass when t is equal to 10 is going to be 50 minus 500 over 10 plus 10. So that's, if we work that out, it's going to become 25 grams. Then for the last part, find the time taken. Okay, we also need to find the time taken, t, when m increase from 0 to 45, that is m is equal to 45, is if you replace m by 45 here, so 45 is equal to 50 minus 500 over t plus 10. You're going to work that out and you're going to end up with t is equal to 90 seconds. And then for the last part of the question, we need to say what happens to the mass of the substance as t becomes very large. So as t becomes very large, so m is going to approach, so t becomes very large as t approaches infinity. So what you can do, you can say t is equal to 1 million. So if you do that, m is equal to 50 minus 500 over 1 million plus 10. So that's going to be then 49.9995 something. So then m approaches 50. Here we are, the last part.